Hi, this is from Dr.B.Vijayakumar, HOD of Physics, SNS College of Engineering. Today we discuss the topic of overview of bending of beams. So the today topic we discuss the overview of bending of beams, right? So in all material to form in elastic nature, the elastic nature is based on to the apply of stress in a material, the strain is created. The strain we call this a bending moment, right? The bending moment is based on to apply of load, right? To the form of two types of bending moment to apply of the load in a different position of the materials, right? We applied the load into both the end of the material, right? It's formed in upward direction bending moment that we call this a elevation, right? Suppose we add a load from the middle of the beam or bar of the material, it forms in downward direction of bending moment, that is called depression. So the bending moment is formed in two types. One is in an elevation upward and another one is in a depression downward. Right? The next one, the bending moment is formed in two types. That called is in an upward and downward. Right? Based on to the form of stress. So the internal bending moment and the external bending moment. The external bending moment is based on to apply of the load. But the internal bending moment is already to form in the material. Right? That means the geometrical parameter and the elastic nature of the material, that is called as an internal bending moment. And the external bending moment, whatever we have added a load, for example 50 gram or 200 gram or 1000 kg like that, in base the bending moment is created. Right? That is external bending moment. So the external bending moment and the internal bending both are equal in nature. Right? It's executed in a constant value of the material. Each and every material they will be executed in a constant elastic nature. So the elastic modulus already we discussed in previous topic wise is a 3: Young's modulus, bulk modulus and rigidity modulus. Right? So this is called as a elevation, upward direction, and the reason means I applied the stress in the both the end of the bar. So the upward elevation is created. The middle portion we applied in a load is formed depressions. Right? So the elevation, whatever the load will be applied in both end be applied in same weight, the same force is acting in opposite direction of knife edge. That's why we get the upward elevation. Right? But in the middle portion we applied the load, right? It's a single load. It's equally separated on two knife edges. So here we form in 50 gram, 25 is here and another 25 is here. That we form in mg, W equal to mass into gravitation, acceleration into gravity, right? 9.8. So this is to be separated in two. So here we form in mg by 2 and mg by 2. One load is equally separated in a depression mode. Right? So this all is a bending of beams. Right? If you have any doubt or queries, right, you ask me, or otherwise you give the feedback of this sessions. Right?
So, after learning all these, how are the different types of modulus applied, sir? Or what are the types of modulus that we use with this bending of beams?
The types of modulus is three. One is a Young's modulus, bulk modulus, and rigidity modulus. Right? It entirely different dimension wise. The one is a Young's modulus. This is to the form of Young's modulus. That means longitudinal stress by longitudinal strains. Right? So the length of the beam it become change. The first one. The second one is a bulk modulus. The volumetric stress by volumetric strain, that is a bulk modulus. So the volume become change in the formation of bulk. The third one is a shearing stress by shearing strain. So the angle deformation is a form of third one of rigidity modulus. Right? Rigidity modulus not only we taken it directly. First we find in what is that? the angle, then after we form in that the relative modulus. But this all is a form of exact constant value to execute a different right? The elasticity it becomes a constant, right? This is the principle of Fick's law. That Brooks law it will be applied in all the types of modulus because that's a basic principle, right? Any questions?
Sir, what are the real-time applications?
This modulus we have identified in all the types of material. We have justified this types of material we have used in the constructions, right, or manufacturing of the engines, right, because the expanded and contraction, that is elasticity, right, it's written back in form of original shape or size after the other property will be changed, right. So this is the very important property we discussed in all the types. So in all the types of material we have used in any types of design or the structure formations, right. First we identify the strength of the material, right. So the strength of the material is based on the elasticity of the material, right. First we identify the elasticity, then we start from the designing or construction of the particular structures, right. So I hope that you have get some idea from this overview of bending of beams, right? So the overview will be given from the our student, right?
So in this session we came to know about uniform bending and non-uniform bending. Whereas in uniform bending, two loads are placed in the either 9 faces of the beam, where elevation takes place. And in non-uniform bending, we place the load in the middle of the beam where there is depression observed. So, and we also discussed about different elastic moduluses and bending moments of external bending moments and internal bending moments of different materials and its properties. And
Thank you very much. We discussed in another one video in another one topics. Thank you.